irrational root theorem. This theorem is only happens when we have a coefficient which is not 1 for the leading term. So your highest power term with a coefficient which is not 1 or -1, which you have 2 or 3, something like that. Well, it might be using the fraction value, or it sometimes still works for the integer value, so you need to try them. Like you can start with trying you can think, oh, we have a coefficient which is not 1. Well, it might be the fractional answer. So we make all these fractions, we can try the fraction first. And if all of the fraction not working, you can go back to try the integers. So what we have in this case, because I'm telling you the integer won't work, I tried all of it. So we put -5/3. We have 3, 8, 2, and -5. So we always have the 3 below. Okay, the 3 is always there. Times them, give me -5. -5 plus 8 give me 3 again. This 3 gives me -5 plus 2, we have -3. And -3 times that is 5. 5 plus -5 is 0. So px can be written in the form of x plus 5/3. 3x squared plus 3x minus 3. And as I said, we can take the 3 out because it's a common factor. We have that. And then we can combine the 3 into the first bracket, which makes the fraction become a 5. Can I still factorize the quadratic? When do you say yes? When do you say no? How do you test it? Discriminant. What's discriminant in this case? What's the discriminant in this one? 5, right? 5. Discriminant is 1 minus 4 times 1 times -1. That's 5. Which discriminant is greater than 0? I can factorize. Okay, I can factorize. So how we should factorize? How we should factorize quadratic? Complete the square, thank you. So we need to complete the square. So complete the square. Okay, put in the bracket. What we have is x plus a half squared minus a quarter and then -1. Okay, skip one step. Plus half of the square and minus half of the square. And then which one you want?
That one? Yeah, that one. I can't less to
Okay, so what we have, well, this one becomes a 5/4. Yep. And then that becomes a √5/2 squared. Well, because no space, I just change everything on this line. So what we will have is x plus a half plus √5/2. X plus a half minus √5/2. That's the fully factorized form. Okay, that's fully factorized. Well, don't just look at the equation and tell me they can factorize or not. For quadratic, you must test the discriminant. you must test the discriminant. Also, like this minus, well, if you have the minus here, definitely you can factorize it because that become a plus. So a positive number plus a positive number, you always get a positive. So you can factorize it. So if you can't see like factorize it easily, what we can do is completing square. Okay, completing square. Alright, so that's this example here. And if you go to the next page, okay, next page is solve cubic equation. Well, to solve cubic, it will be the same as factorize. You need to factorize the cubic and then non-factor law. So you need one side equals to 0. Okay, you need one side to be 0 in order to use the non-factor law. That's how you can, well, not only cubic, well, I can change the word to polynomial. Well, solve all the polynomial equation, that will be the same. You factorize it and then make one side equals to 0. Then use non-factor law to it. And then how many solutions you can get. You can see it very easily. So the first example, it just shows us what we can have is x minus 1 equals to 0, or x plus 1 equals to 0, or x plus 3 equals to 0. X equals to 1, x equals to minus 1, or x equals to minus 3. So 3 solutions. Okay, 3 solutions. Next one the same, 2x plus 1 equals to 0, or x minus 3 equals to 0, or x plus the third equals to 0. So x equals to negative a half, or x equals to 3, or x equals to negative a third. Questions? Well, this one is factorized for you, so we can directly use the non-factor law. We can have a look at the next one, which is in the expansion form. But what you realize is there's no constant. There's no constant term. That's the fantastic thing. Because we can remove the highest common factor, not really remove, factorize the highest common factor, which is x in this case. Because all the term contains x, right? If we have constant, we can't do that because we don't have x in the constant term. But we can take x out. X squared plus 2x minus 10. That equals to 0. Can I factorize that further? Yes, I can factorize that further. So what I can do is this will become x plus 1 squared minus 1 and then minus 10 equals to 0. Well, 2x, x squared plus 2 plus 1 minus 1 and then minus 10. So the first return becomes x plus 1 squared. So x plus 1 squared minus root 11 squared equals to 0. So x times x plus 1 plus root 11, x plus 1 minus root 11 equals to 0. Okay, in the first step, cannot divide x on both sides. Okay, cannot divide x on both sides because x could be 0. Well, you can't divide 0 on both sides. You can't divide 0. So x could be 0, so we can't divide unknown variables. So what we need to do is take that as a common factor. If you divide it, you will lose one solution. Okay, you lose one solution. So what we have in this case is x equals to 0 or x equals to minus 1 plus minus root 11. Okay, the two bracket, minus 1 plus minus root 11. Alright, next one. Next one, we can take x out. So 2x squared minus x minus 1 equals to 0. Well, I think this is a pretty good number. 1, 2, 1, 1 minus 2 plus 1 gives you minus 1. So I can factorize that directly. 2x plus 1 and x minus 1 equals to 0. This one can be factorized directly. You don't need to go for completing square. So we have x equals to 0 or x equals to 1 or x equals to minus 1 on 2. Questions? Okay, for the next one. Well, for this one, there are two ways to do it. Okay, there are two ways to do it. I want you to understand both methods. The first one is, well, I can solve it directly. You can see we can solve it directly without factorize because x cubed will equals to minus 8. Well, what type this belongs to is sum cube equals to a constant. Okay, this form is sum x cube equals to a constant, and then I can solve that directly because I can take a cube root on both sides. What I have is x equals to -2. That way I can solve that very easily. Well, same as this one. This gives you 1 over x cubed equals to 1000. So 1 over x equals to 10. Cube root both sides, and x equals to 1 over 10. That's the really straightforward method what we can do. But there's another thing we need to think about. If we factorize it and then solve for it, we should have the same answer. Okay, we should have the same answer. Also, I want you to revise on like the factorize of a cubed plus b cubed and a cubed minus b cubed. So what we have in this question is x cubed plus 2 cubed equals to 0. So what we will have is x plus 2. Well, a squared, which is x squared, minus ab, which is minus 2x, and plus b squared, which is plus 4. Can I factorize that further? Can I factorize it? Well, if you test the discriminant, we'll say no. But you also need to remember, when we use this formula, this quadratic cannot be factorized for sure. Remember I said that before? So if you use this a cubed minus b cubed or a cubed plus b cubed formula, the quadratic you have cannot be factorized for sure. The discriminant must be less than 0. I have talked about that one in the end of the last lesson. Remember, see? What I write here cannot be factorized over there. So page 61, I was talking about that as well. We can see all these examples shows you can't factorize it. So you can't factorize it means your discriminant is less than 0 already, right? You can't factorize it means your discriminant is less than 0. So the only solution we have is x plus 2 equals to 0, x equals to minus 2. No solution here. Even though you make that equals to 0, you don't have any solution from that quadratic. So that's why we still have one answer. Okay, example 7. X cubed plus 4x squared minus 3x minus 12. Well, when we see this, what we can do is find the value like 1 plus minus 1 plus minus 2 plus minus 3 plus minus 4 plus minus 6 plus minus 12, like to try a value to make it equals to 0. But if we observe the coefficient, that looks very special. So we have something grouping. Well, you use grouping only if you can see it. If you can't see it, you just do use the normal way to do it. Okay, it doesn't matter. Like, it's not some question you must use grouping. No, it's not like that. But if you can observe the coefficient and you can see some special things using, or it might be grouping, then we use it. Otherwise, if you can't see it, that's fine. So what we have here is, where's my question? Here, okay. We can group those two. We can take x cubed out and then x plus 4. I can take a minus 3 out for the next two. We still have x plus 4. That equals to 0. So x plus 4 become the new factor, and we have x squared minus 3 equals to 0. Well, can you see if you try minus 4 in this question, you will still get the same question, like same answer. You still get the same thing if you try minus 4. So as I said, plus minus 1, plus minus 2, plus minus 3, plus minus 4, plus minus 6, and plus minus 12. Only minus 4 works. Okay, only minus 4 works in this question. So you can still try it. You can still try it out, and you get the same thing here. But it's obviously easier to use the grouping method for this question. So we have x plus 4, x plus root 3, and x minus root 3. And that equals to 0. So x equals to minus 4, or x equals to plus minus root 3. Alright, example 8. Well, you can see the 11 and the 11. That's a good hint to tell you we can use the grouping method. Okay, that's a good hint to use grouping method. So we can still take those two and those two. So x squared gives me x minus a, and minus 11 gives me x minus a equals to 0. So x minus a become the new factor. X squared minus 11 equals to 0. X minus a here, x plus root 11, and x minus root 11 equals to 0. So x equals to a, or x equals to plus minus root 11. Well, you can see I tell you this is grouping question, so you can very easily think, oh, group those two, group those two. But when you actually factorize things, no one will tell you which method to use. So you need to think, you need to try to remember. Okay, so do we have constant? If we don't have constant, that's the highest common factor, like take the x out. If it's only something cube equals to a constant, we can use the previous one. And if we can think, oh, some coefficient looks really the same, and we can think about the grouping method. And if we can see the next one is there's nothing really we can do. Okay, there's not really something we can do. Well, you can see, okay, you can see this. Can you see the coefficient? We have 2x cubed minus 2. Well, if we put those two together, and we have that. Well, let's try, because if there's nothing like information give me, I see coefficient looks pretty much the same. I will try to use grouping to see if that works or not. Maybe not, okay, maybe not. So what we have here is 2x cubed minus 1 minus 5x x minus 1. Okay, that's what we have. We don't have the same thing now after grouping it, but that's okay. Okay, that's okay, because what I can do is, okay, we have x. Okay, what we can do here is I put x minus 1 here, I factorize it, and I have x squared plus x plus 1. Well, I haven't think it before. I can use grouping to do this question, or I can use some similar method to do it. That's just a try and error process. Okay, I just tried. I'm not sure what I can end up with. I think the coefficient looks the same. I can group them together, and I might have something. So this is something I might have. So what I have now is I can see x minus 1 as my coefficient. So I take x minus 1. We left this one is 2x squared plus 2x plus 2. And then minus a 5x. Okay, and that equals to 0. So what I have is x minus 1, 2x squared minus 3x plus 2 equals to 0. Do I get it right? I'm not sure. I'll try. Well, we have coefficient 2 minus 5, 5, and minus 2. And the value I want to try is 1. Put 2 here. Minus 3, 2, 2, 0. Okay, so 2 minus 3 and 2. Okay, it works. So it should be this as well. And I can see the discriminant for this one is 9 minus 4 times 2 times 2 is something less than 0. So I can't factorize. Okay, I can't factorize. Therefore, I only have one answer, which is x equals to 1. X equals to 1. Can you see like this question I'm supposed to use the box method to do it, but I suddenly see, oh, I can also do it by group it together. So that's just another thing I just realized. Okay, it's just that moment I realized, oh, I can use grouping. So that's what I have tried. Not only one way you can work out the solution, there's multiple ways we can try it. So if you don't like my current method, you can also set up the table here and then say we can try 1 or -1, 2 or -2, and then you have this thing here. We can directly jump, well, it's a long method. Okay, my method is a long method. I can directly use this box and jump into this step. Okay, save you quite a lot of time. So different things got different way to do it. Some method can make this question quicker, but other questions slower. So if you use grouping here, it's quicker than the box method, because if you use the box method in this question, you need to try -4. It's not that easy to think about -4. You will start with -1, -2, +1, -1, +2, -2, and then +-3, +-4. So you may try it like in very late. So it's not a quick method for that one. But the box method is a really quick method for this question. We try one, we directly get the answer, and then we jump into the second last step, and then we make the conclusion. It can't factorize further. We have x equals to 1 here. Okay, x equals to 1 here. Alright, the last example 11. Okay, example 11. I'll give you 5 minutes. You think about the best way to do this question. Okay, all the things we have done above, they are good method. So you choose a method to think about this question. Which way you think is easier to do this one? What method we choose to that? Grouping, like which two group together? 2x cubed minus 2 for 2x and minus 9x squared plus the 1089 equals to 0. Yeah, like that. So we group those two and we group those two. Why we think about grouping? Because the number is too large. I don't want to use the box method to try them. Like, it's too hard to do it. And also it's hard to find out the factor. So, well, what I will think for this question, well, I don't know whether I can use grouping or not. But what I can see is 1089 is divisible by 9. That's my starting point. 1089 can be divisible by 9. Because when you add all the digits, that is equals to 18. So 18 is divisible by 9. So I know this number can be divisible by 9. So we have 1, 2, 1. Okay, we have 1, 2, 1. And also you can see the 2 and 2 for 2 will give you 1, 2, 1 as well. So I will think about the grouping. We have 2x, x squared minus 1, 2, 1, minus 9, x squared minus 1, 2, 1. That equals to 0. So x squared minus 1, 2, 1 gives 2x minus 9 equals to 0. So x plus 11, x minus 11, 2x minus 9 equals to 0. I need to correct the paper. So what we have is x equals to 9 over 2, or x equals to plus minus 11. Alright, that's this question here. So the rest of the time, I want you to factorize questions on page 65, 66, and page 70. Factorize those polynomials. If you can't finish it, you just do it as homework. Okay, factorize those 3 pages. 70, 65, 66, and 70.